Drilling into concrete is one of the highest vibrating disciplines. I'm James Kitchen from DeWalt, and today we're going to run through tips and techniques on how to reduce vibration and not reach exposure levels while drilling with SDS drills. Some of the technologies you're going to see today are exclusive to DeWalt. However, the tips and tricks we're going to show you are universal. Please feel free to use the chapters below to skip to the bits that are most relevant to you. Here we have a hollow drill bit, which is slightly different to our normal range of drill bits, but this is designed to remove dust from the point of the tip and not from the flute as it's exiting the hole. This helps to reduce the dust into the air, which is dangerous to the user. For different substrates, you'd use this in a slightly different way. So in soft brick and block, what we'd normally recommend is to take the hammer mode off and just run it in rotary to begin with. This will help pierce the brick and create a little bit of a pilot, which will then allow you to then turn the hammer mode on and drill the hole as you would normally. In harder substrates and with bigger drill bits, we'd normally just recommend using the hammer and rotary function, and that will help reduce the dust. So with this unit, it's slightly different to the rest of the units that we have in our range of SDS. So rather than the handle floating, it is actually the motor and gearbox. So it's this bit in the middle that's actually taking the vibration away from the arm. And this is the important bit for anti-vibration technology. The less vibration that's reaching the wrist, the less vibration that is being entered into the body. And that's why we've come up with some very clever technology to help reduce that. As you can see on this, where the dial selector mode is, if you push that, you can see just how much that's taking out of the trigger. And that's the important bit. With the larger SDS Max drills, and other SDS drills that we have in the range, it's this bit at the handle that is taking that vibration away. Let's see how that performs. As with any drilling, letting the SDS drill do the job it's designed to do is really integral to how this is going to perform. So letting the drill bit do the work and allow it, giving it space to do the impact, is where the difference is going to be held. If you try and force this too much, it'll stop the bit from moving back and forth in the hole and slow down the drilling process entirely. This is the same for both hollow bits and for fluted bits, and all the flute is doing is drawing the dust away from the hole. So allowing the tool to do the work is vitally important for the vibration that comes back through the arm. As we've discussed, both of these have got an anti-vibration technology within them, whether it be floating handle or floating gearboxes. First, we're going to cover PPE. So as with any drilling into silica creating dust, you're going to need a good pair of goggles, a good safety mask, and a good pair of ear protection, whether that be in ear or over face. We'd also always recommend gloves. So for this demonstration, we're going to use an SDS Plus drill. We're using a hollow bit here, but any SDS Plus bit will be suitable. Here we're going to use the soft blocks. This is soft internal block. So to start, we're going to turn the hammer off just to make the pilot bit. And what that will do, it will stop the brick from blowing out at the front, but also allow a level of precision. So it means that where you put the drill bit is where you're going to make the hole. And because this is a hollow bit, we're going to hook this up to the dust extraction, and that will pull the dust away from the tip, thus allowing for a clean, safe hole and not introduce the silica dust into the air. Always have two hands on the machine. Not trying to be a superhero, one hand these things. These are quite dangerous, there's a lot of torque here. Always braced, always stanced. What you don't want to do is be chucked off the position that you sat in, because the drill is then turning and pushing you away from where you want it to be. As you can see, reducing vibration is quite important. The Health and Safety Executive published guidelines and a handy calculator to work out vibration exposure. This is measured as EAV, or exposure action value, and ELV, which is exposure limit value. The ELV is the maximum level exposure you should be exposed to on any given day. The EAV is the maximum exposure level before an employer has to take note of the vibration and take action to reduce the vibration. Using that handy calculator and the instruction manual, which will publish the vibration levels of each of the tools, you can work out the maximum exposure level you should be exposing yourself to with any tool. If you compare our older SDS equipment to our new SDS drills, this is our 2 kilo SDS Plus drill. This has a vibration level of 6.6 meters per second squared. It's incredibly low for a 2 kilo SDS hammer drill. If you compare that to what we had before, that would often be double to triple the amount of vibration. And when you pop that data into the HSE calculator, you'll see the time that you can use the compact cordless SDS drill versus the older corded drill is substantially higher, sometimes 2 to 3 times more work time. This enables you as a user to use this tool for much longer. It means you get more of the job done on site and less of the downtime that you need to take a break between those exposure levels. So while this reduction in vibration does allow you to use the tool for much longer, there are certain tasks and applications that will require longer drilling time. For those sorts of applications like drilling rebar into concrete, we'd normally recommend rotating users out so that they never reach that exposure limit value. For larger jobs, and certainly for job site tasks where monitoring this type of vibration level is really important, there are things like health monitors that can monitor vibration through the arm of the operatives and get logged automatically. This is critical on larger job sites, but also where there's multiple operatives on site. As we've seen in this video, even with modern technology reducing vibration, you could see just how much vibration was transferred to my body. It's really important that we pay attention to vibration levels, use the manuals and the HSE calculator to make sure we're the right side of those maximum exposure limits. Thank you for sticking around to the end of this video on vibration reduction in SDS drilling. Stick around and keep an eye out for our next video around core drilling, and don't forget to like and subscribe for more practical engineering guides.